welcome to Tech Talks. My name is Rod Soto, and I'm here today to speak to you about detecting Trickbot with Splunk. Tech Talks is a series of short webinars that are deep dives for technical practitioners. We value you, our customer, and want you to continue with your Splunk journey. Our experts help create these best practices, and we want you to leverage them in your daily role. So let's get started. My name is Ron Soto, and I have around 15 years of experience. Been working in Splunk for the last 2.5 years on the role of Principal Security Research Engineer. Previously worked at Prolexic Technologies, Caspita, and then finally Splunk. And I'm here today with Eric Contreras, and I'm gonna let Eric introduce himself.
Hello guys, my name is Teodric Contreras and I'm one of the senior threat research engineer in Splunk. I can say I'm more than 12 years of experience in cybersecurity, mainly focused on malware reverse engineering, digital forensics, and blue teamer. I'm a ex-Microsoft and ex-Trender and also Airbus cybersecurity and now working for Splunk.
Excellent. We're both part of the Splunk threat research team, which sometimes we refer to as STRT. And basically what we do at STRT is research that includes current, past, and present malicious activity. We also focus on ongoing campaigns, and we also do things such as research, threat exploitation, case studies, creation of data sets, detection building, response playbooks, which usually develop based on Splunk SOAR. And most of all, we like to share our work with the community. We have regular releases, which you can find either in Splunk base or in our GitHub page. So let's take a look at a little bit about our agenda. First, what is Trickbot and why should you care? Second, detecting Trickbot with Splunk. Then we're going to have an amazing demo of reverse engineering, and we're going to show you the analytic story that we created for addressing this threat. And finally, we're going to go over some additional resources. So what is Trickbot? Trickbot, first of all, is a popular crimeware carrier, actually known as a Trojan. Trojan basically is code that sometimes might be embedded in things that are apparently not malicious, but they are. So what happens many times is this code is stealthy, it's versatile, and it's versatile because it can download or install subsequent payloads that have different functions. Some of them will be shown today during this talk. Trickbot appeared in campaigns around 2016, and it's been said to be related to Duressa, which is also related to SUSE. SUSE is the father of all botnets, and quite frankly, the crimeware history is probably before and after SUSE. And then we have Trickbot as a very popular crimeware tool right now, and it's a major driver for building botnets. So let's explain a little bit what a botnet is. A botnet is a network of compromised devices that usually communicate over the internet. Sometimes they communicate with each other, but mainly they have one node they communicate with, which is the command and control center. And this command and control center is where criminals or the operator, the bot master as is known, execute commands or download payloads remotely into many of the devices. If you look at this slide, there's all kinds of devices from desktop, laptops, servers, even internet gateways, or sometimes known as CPEs, can be compromised and be used as what is called zombie. A zombie in botnet terminology is a compromised device that is under control of the C2. And then we have things such as even tablets or phones and all kinds of IoTs. I personally seen in my life research that anything can be compromised and basically controlled remotely by a botnet. The reason why these botnets are built in the underground economy is because they're profitable. Once you have a number of devices that you have compromised and in which you can execute remote code, there are many activities that you can perform that would reap profits very quick. Currently, we're looking at things such as crypto mining, which is basically using the device that has been compromised to create a cryptocurrency. So if we looked at, for example, Bitcoin or Monero, Monero especially because Monero doesn't need a GPU, which is a graphical processing unit, in order to be mined. You can, if you have a large number of these devices and you point it into what is called a mining pool, you can actually create cryptocurrency, then exchange it and make actual fiat currency. We also had things such as ransomware, which is obviously very well known as the current ongoing campaigns, where basically you cipher most of the system, leave it barely functioning, and then request a ransom. Nowadays, we're also looking at things such as the double extortion, where not only a cipher is placed into the main files or folders or shares or systems, but also sensitive information is exfiltrated, and then you are blackmailed into publishing sensitive information if you don't pay, which is called the double extortion. One is basically shaming or publishing sensitive information, and the other one is obviously the ransomware itself. And we also had sort of like the classic botnet activities such as carding, which is the basically cloning or using credit cards for banking fraud, which we're going to look today in the form of webinjects, and DDoS, which is basically attacking targets. You can actually rent a botnet for performing DDoS attacks, and this actually produces a lot of money. In the case of Trickbot, I'd like to highlight, we are going to be looking at mostly Windows compromised endpoint devices. So here's an example of how this compromise occurs. Basically, the main common infection vectors are either spear phishing, basically sending you an email with a malicious payload. Sometimes they brute force into most likely companies where password policies are weak, or you don't have, for example, multi-factor authentication. You expose mail servers to the internet. You have legacy or VPNs that are misconfigured. They don't have multi-factor authentication. You have a federated environment where the password is basically repeated. So all what I had to do was crack one, and then I go all over your infrastructure, including accessing VPN, and now I'm inside your perimeter. Other things will include also exploiting the VPN itself, or if you expose, for example, Windows servers or Linux servers, you can exploit them directly. And we have seen recently cases where a supply chain has delivered the payload, which is kind of ironic, but this is also happening. Basically, third-party providers that you may have can be compromised by malicious actors. As they compromise your third-party provider, like an MSP, they can actually deliver by embedding their code into the application that you are using from them, and then that subsequently ends in full compromise. From there, assuming that you're able, or the criminal is able to get a hold of a system, basically Trickbot payloads are installed in multiple stages. And attackers will likely, which is common, establish persistence, move laterally, and exfiltrate data, right? And usually what I've seen in the field is that once you have exfiltrate data, the ransomware is like the cream of the crop. Like, I already have all your data. I'm just gonna cipher all this and charge you more money. So here's an example of a payload that was delivered, that we found that was delivered via a macro embedded into a Microsoft Excel document. And I'm gonna let Theoderic talk a little bit about this one specifically.
Yeah, sure. Actually, this macro uses interesting technique to hide its malicious code from analysts and normal user. This is done by creating a hidden Excel sheet where the XLM macro are placed with white font color. So by hiding the Excel sheet, like what we saw in the screenshot, and making the font into a red color, we were able to see its code that it tries to build, like a run DLL32 command line to execute the downloaded payload, a DLL name as gver.iks with a parameter STRT.
Excellent. So here's another example of how Trickbot actually delivers modular payloads, and that makes it very popular in the underground economy. Remember, the more usability, to put it a certain way, features, to put it a certain way, it's almost like a product within the underground crime environment, the more these criminals can make money. That's why it's so versatile, and they create customized a la carte type of payloads. Like in this case, and I'm going to let Eric talk about this again.
Yeah. As an additional information, we can see in this slide several screenshots. One of them are eternal blue code used by the worm DLL64 module of Trickbot, which is used to do a lateral movement to compromise more hosts or machine in a targeted network. We can also see the code of Network 64 DLL module, where it used an LDAP query to locate the administrator account to gain privilege escalation to the compromised machine. And finally, the PS Info 64 DLL module, where it also executes LDAP query to parse the domain of the compromised host to check if it is in the point of sale network domain as part of its purpose as a banking Trojan.
Excellent. So now let's show you this, which is a highlight actually of what we wanted to talk today. One of the things that we found during our research is a module basically that basically matches or relates to webinjects. So webinjects basically are a specific and sophisticated payloads that basically target financial institutions and operate in the background sessions without the victim having knowledge. So they imagine that somebody is accessing their bank, right? Imagine that there is a webinject in this compromised machine. Criminals are able to execute transfers and other fraud-related operations. And usually this happens because the destination of these transfers and operations are foreign financial institutions where cybersecurity laws are lax, and this has become possible. In the latest version that we reviewed, we also discovered actual cryptocurrency exchanges, which is something novel, and tells us that obviously the criminals had taken notice of all this cryptocurrency, I guess, movement, or a lot of people putting money into cryptocurrency. And now they are indeed targeting cryptocurrency exchanges, not just banking institutions. And we were able to observe that in our research. And here is an example of how the webinject looks like. In the past, I remember I researched webinjects during the SUSE era. Basically, you had to buy an entire package of PHP code, and it cost a lot of money. That's just that module. The criminal has to make an investment, actually. In this case, we see that they have actually improved the way the injects are performed. And I'm going to let Eric tell you a little bit how this happens.
Yeah. So in this screenshot, we can see the decrypted web inject config file of Trickbot. downloaded from its C2 server. Aside from that, to decrypt this module, it downloads a DLL name as inject DLL64, that DLL that will decrypt this webinject config file into a XML file format. So once the Trickbot injected to the browser and monitor the user, once it connect or access the targeted web page or banking web page, it will contact this DLL and look for this XML web inject config file. If the web page of the banking URL accessed by the user is in the field of LM, as we can see here, it will be redirected to the spoof website created by the Trickbot that we can see in the HL field. In this way, the Trickbot lure the user and steal banking information.
So that's one example of how these things operate in the background, and they're very stealthy and very hard to detect. So with that in mind, we decided that we wanted to tackle this threat. And then we created an analytic story that you can find in our GitHub and Splunk base. Name, obviously all stories have a subject. The subject of this one is detecting Trickbot. And then as you can see in this analytic story, which is basically several detection searches, sometimes investigations, or even playbooks, they're put together within a subject. Like I said before, and this subject is Trickbot. And as you can see in this graph, there are several detection searches that include several TTPs. We try to make it easier for you to understand it, so we use MITRE attack type of nomenclature. And here's an example, one single example of T1053, which is in this thread specifically seen in the form of using scheduled tasks to use run DLL to execute commands. And just like that, there are many more. So please take a look at the highlight URL and visit it for detailed specific information of how we basically built this story and by the specific TTPs associated with Trickbot. And with that, we are ready to watch an amazing demo by Eric. And we're going to show you how Trickbot was reverse engineered and analyzed.
Thanks, Rod. In this demo, we will show you 2 examples how reverse engineering the code of Trickbot help us to develop SPL detection using Splunk's attack range. In the screen shared now, we loaded the Trickbot unpack code that was carved out from the memory in the Ghidra reverse engineering tool. We will not go deep on each of the code, but we will only focus on the interesting string that we can see in defined string view. Here, we can see that the string was cross-referenced or used in some of the function of Trickbot code. So by decrypting or decoding this string might help us to figure out what is the actual behavior of Trickbot. So we decided to extract those strings, place it in a text file, as well as the decoding key used by the Trickbot, and a Python script where we simulated the decoding function, which is a base64 algorithm with a customized base64 index table. By running this script, we can see right away several notable strings, especially the different public IP lookup service domain. These domains are used by Trickbot to recon on the compromised host to gather network information like IP addresses as part of its execution. This behavior is really unique and suspicious that can distinguish Trickbot infection, and later we will show you how we use those strings as a detection. The next one is the Trickbot share64 DLL.dll module. As you can see in this EW, that it has several functions that it may execute during the infection. But we will just focus on the function named as drop exe in network share. This function tries to build a string in stock that are pertaining to dropping a copy of Trickbots malware to a network share using copy file W API. So you can see it will try to drop in C share and also in admin share. Since Trickbot is C2 driven malware, sometimes during analysis, we may not be able to grab or see all the Trickbot modules in a affected machine. Or maybe the payload is different, like Cobalt Strike. But by reversing this code, we can simulate it using a simple batch script that we can see here. That will drop a executable in network share. So by running this simple batch script, we were able to simulate that one even we didn't manage or we didn't execute the actual module. Now we will show you how we use this information in detection development. For simplicity, we already loaded the data sets we have during Trickbot testing in this search head. First, we use one of the IP services domain we decoded during our analysis. And in this event, we noticed that the where manager process is trying to do a query in one of the domain we saw in our analysis. And this where manager, the TXC, is a process spawned by the actual Trickbot malware to inject its code and do its malicious behavior. So by compiling all those IP domains, we were able to detect the actual behavior of this Trickbot connecting on those IP lookup services domain. The next one is how we detect the share 64.dll behavior or lateral movement by dropping copy or executable in a share folder. So you can see here we use event code 5145 with an access mask of 002, which is write access in any of the share name listed in this search. And by running it, we were able to see that we catch the simulated sreceive.exe that we ran previously.
After that amazing demo, we want you to continue your Splunk journey. And for that, we have some additional resources that you can actually check after this tech talk. As we're about to wrap up, here's some things that you can take a look at as that have been mentioned. One is the content updates, which you can find directly in Splunk Security Content or GitHub. Also, we have a blog where we address this thread in a little more extension than what we did in this tech talk. There's a Trickbot blog and there's a URL, so you can go and read it. We also have a white paper, which is even deeper, technically speaking, as far as addressing this threat and some other things that we mentioned during this tech talk that you may want to research on. Of course, we have our community Slack, which you can always join and ask questions actually directly to us. And of course, the STRT page, which is where we publish our latest research, opinions, statements, assessments of current and ongoing threats. And you can always give us some feedback because we truly appreciate it. Remember to continue the conversation on our community sites. We have an incredible community of Splunkers, and many topics and answers can be found by either peers or documentation that has been published online, which may be incredibly helpful for you in your journey. And again, don't hesitate to reach out to us. And with that, we really appreciate you taking the time out of your schedule to join us today. Please come back for future Tech Talks as we are excited to share this series with you.